Now in today's session, we will study about the P block element. Now P block element. Now P block elements are found in the extreme right of the periodic table. Now you can see here that this is a complete diagram of the periodic table here. That is, now we have to study the P block element, which is towards the extreme right of the periodic table, and it is from group number 13 to 18. Now this 18 group is taken as noble gases. They also are included in P block except the first element of the 18 group, helium, that has configuration 1s2. Now this group S block consists of group 1, 2 and group number 3 to 10 transition elements. D block we have to study in separate chapter, and F block. Now slightly detail period wise. The first period does not contain any element in the P block. It starts from the second period, and the second period, that is 2p. 2p means nitrogen family, the period in which nitrogen is present. 3p, that is third period. 4p, fourth period. 5p, fifth period. Likewise it goes on. Now introduction of this chapter. The P block starts from period 13 to 18. That is group number 13, that is boron family. Group number 14 is carbon family. Group 15 nitrogen family. Group 16 oxygen family. Group oxygen family is also called as chalcogen. Group 17 is halogen family, and group 18 is inert gases. In this chapter we have to study, that is the first group, group 15th. Group 13 and 14 we have already studied in class 11th. Its general electronic configuration is NS2 and NS2 NP 1 to 6. For example, now we are studying group 15th. So group 15, the first member is nitrogen. So it is 1s2, 2s2 and 2p3. So just now we have studied NS2 means here 2s2 and NP 1 to 6. So complete, they have given the general electronic configuration. So for 15 group, nitrogen. So the group included in the syllabus are 15th, 16th, 17th and 18th. Now the occurrence of the 15th group element. First, that is molecular nitrogen 78% by volume. 78% by volume. In earth crust it is obtained as a mineral sodium nitrate. Commonly it is known as Chile saltpeter. Second mineral is potassium nitrate, that is Indian saltpeter. It is also found in the form of proteins in plants and animals. Now phosphorus is found as a mineral as a apatite family. Its formula, general formula is Ca9PO4 whole 6 dot CaX2, where X may be fluorine, chlorine or hydroxy group. If it is suppose fluorine, it is called as fluoroapatite. If it is chlorine, chloroapatite. OH is hydroxyapatite. Phosphorus is also found in plants and animal matter. They are also found in bone, milk, egg. So they are important part of our life. The rest, that is the 3 more elements of this group, they are present as the form of sulfides. Arsenic, arsenic sulfide. Then antimony, antimony sulfide. Bismuth, bismuth sulfide. So these are the occurrence of the group 15. Now, how they occur in the periodic table. In periodic table, these elements are found in the form of metals, non-metals and metalloids. So we are studying here group 15th. Now group 15th, you can see here, that is nitrogen and phosphorus, they exist as non-metal. Here it is written blue color non-metal, yellow color metalloid and brown color is, that is metal. So first 2 elements of this group, nitrogen and phosphorus, are non-metals. Arsenic, this is arsenic, and antimony, they are metalloids. And the last one, that is bismuth, is a metal. So this is the occurrence of these elements in the form of different elements, metal, non-metal and metalloids. Now group 15th elements. The member of the group 15th are nitrogen, phosphorus, arsenic, antimony, bismuth. In nitrogen, we have to study all the oxoacids of nitrogen, ammonia. In phosphorus, we have to study PCl3, PCl5, PH3 and oxyacids of phosphorus. Now comes to the electronic configuration of the element of this group are. The general electronic configuration of this group is NS2NP5. NS2NP5. Now here you can see the nitrogen is a member of the second period. So 2s2 2p3, phosphorus third period 3s2 3p3, arsenic 4s2 4p3 and antimony 5s2 5p3, bismuth 6x2 6p3. Now you can see the abundance in the earth crust. So this is no need to remember. Again, one more thing I will tell you, that you can generate the atomic number of the elements next to the 8. For example, nitrogen, if you will the atomic number of nitrogen 7, add 8, you will get 11. Add again 18, you will get 33. Add 18, you will get 51. Add 32, then you will get 83. So likewise, if you do not know the atomic number, you can generate yourself if you know the series regularly: nitrogen, phosphorus, arsenic, antimony, bismuth. No need to learn it. Now the properties of the 15th group element. The first property is electronegativity. Now what is electronegativity? This we have studied in class 11th. Once again I will repeat. Electronegativity is the tendency to attract the shared pair of electron towards itself. So down the group, the electronegativity of these elements decreases. Down the group, the electronegativity of the, it means in the group nitrogen is the most electronegative element, and you know that it is a non-metals. So non-metals have higher electronegativity and metals have higher electropositive character. So in the group, as first, that is nitrogen is electronegative, whereas bismuth is electropositive. Second is ionization enthalpy. Now ionization enthalpy of, what is ionization and enthalpy or ionization energy, both are same. Ionization energy is the amount of energy required to remove or to knock out an electron from the isolated gaseous atom. मतलब किसी भी एलिमेंट से अगर इलेक्ट्रॉन निकालने के लिए जो भी एनर्जी की ज़रूरत पड़ती है उसे हम आयनाइजेशन एनर्जी कहते हैं. अब हम आते हैं एक कुछ क्वेश्चंस जो कि बोर्ड में आते हैं. पहला है दैट इज नाइट्रोजन हैज़ हायर ionization energy than oxygen. Why? Nitrogen has higher ionization energy than why? So this we can answer on the basis of electronic configuration. Very important question. Many times it has been asked. If you write down the electronic configuration of nitrogen, it is 1s2, 2s2, 2p3, and here you can see that the s orbital of nitrogen is fully filled and 2p3 orbital is exactly half filled. So they attain extra stability. They attain extra stability. That is why the ionization energy of nitrogen is higher than oxygen. This question is very important. Many times it has been asked. So it is 2p4. So here you can see that it is not exactly half filled. P orbital is not exactly half filled. One orbital has 2 electrons and 1 each. Now if you compare the second ionization energy, then you can see the second ionization energy of oxygen will be higher than nitrogen, because when you will eliminate one electron from oxygen and nitrogen both, so oxygen will have that exactly half filled orbital, so that again it will be more stable. So always remember कि whenever you have to answer the question of ionization energy, always draw that is electronic configuration. Now as you move down the group, the ionization energy decreases. Why decreases? Because the shells goes on increasing. Nitrogen has 2 shells, whereas nitrogen phosphorus has 3 cell, nitrogen phosphorus arsenic 3, like 4 cell. So it goes on increasing. So the size increases, ionization energy decreases. Third point is that is atomic radius. Now what is atomic radius? Atomic radius is the average distance between the 2 nucleus of the bonded molecule. For example, nitrogen, 2 atoms of nitrogen when they combine, this is one atom of nitrogen and this is second atom of nitrogen. This you have studied in class 11th. So this is the half. Average distance between the 2 nucleus gives you the atomic radii. Now again, as we move down the group, the atomic size increases. Third is that is electron affinity. Electron affinity is the energy released when an atom accepts an electron to become, that is, negatively charged ion. So as we move down the group, the electron affinity decreases. Now why decreases? Because as we move down the group, the size increases, so the tendency to accept electron decreases. The nuclear charge or force of attraction between the nucleus and the valence shell goes on decreasing. Next is melting point. Now what is melting point? Melting point is the amount of energy required to break bonds to change a solid phase into liquid phase. So as we move down the group, the melting point increases down the group. Now you can imagine that nitrogen is a gas, phosphorus, arsenic, antimony, they all are solid. So as the gases has actually boiling point, but if you liquefy it and then freeze, then it may change into solid, but it is gaseous in nature. So you can think over it that it always has lowest melting point in the group, and bismuth has the highest melting point. Now why we have to study according to melting point decreases or increases? In the board, questions is asked in the form कि arrange these elements in the increasing order or decreasing order of melting point, electronegativity, ionization, anything they can ask. So that is why you correlate one property with the other, then you can get the answer. Last is boiling point. So boiling point is the temperature required to change the liquid phase into gaseous phase. It also increases down the group. Now ionization energy, that is one successive ionization energy. Successive ionization energy is the energy required to knock out electron. First electron, first ionization energy, second electron, second ionization energy, third electron, third ionization energy. So if we compare these successive ionization energy, always the third ionization energy will be greater than second. This is H1. Then I is ionization energy, H2 greater than the I. This is reverse, it is H2 is greater than H3 is greater than H2 is greater than H1, because the electrons has to be eliminated from a charge species. जब एक इलेक्ट्रॉन निकलेगा तो उस पर चार्ज आ जाएगा, और जब इलेक्ट्रॉन निकालना होगा किसी भी चार्ज स्पीशीज से तो ज़्यादा एनर्जी की ज़रूरत पड़ती है. Now next is physical properties of the 15th group element. Physical properties of the 15th group element. Number 1, that is they are polyatomic. The element of the group 15th are polyatomic. For example, nitrogen is diatomic. Nitrogen is diatomic. Then phosphorus is tetraatomic. Now this already we have discussed, that is nitrogen and phosphorus are non-metal, arsenic and antimony are metalloids, and bismuth is a metal. Boiling point also will. Now the last point of the, that is allotropes. Now the elements of this group can show allotropy. Now what are allotropes? Allotropes are the existence of the elements in different structural arrangement. So they are called allotropes. So except nitrogen, all the elements shows allotropy. Except nitrogen, all the, in NCERT it is not given, that is nitrogen do not show allotropy, and phosphorus, it shows three kind of allotropes: white phosphorus, red phosphorus, black phosphorus. Then they have the structure here, that is it has white phosphorus as tetrahedral structure and it is highly reactive. White phosphorus has tetrahedral structure, highly reactive because the angle between these phosphorus atom is 60 degree. So it is highly strained, can be easily broken. Therefore white phosphorus is highly reactive. And the black phosphorus is polymeric in nature, and the red phosphorus is straight chain compound. And in black phosphorus you will not see that is a square actually form. The bond between this phosphorus and this phosphorus is not formed, only this bonding is there in red. So red question is asked, which one is more reactive? So white phosphorus is more reactive than red phosphorus due to the strained structure. The angle between them is 60 degree. Next is arsenic. They also have three allotropes: yellow, black, gray metallic, antimony, yellow, metallic, explosive, and bismuth, no allotrope. But only the important one is of phosphorus, we will discuss in detail. Now chemical properties of nitrogen, phosphorus collectively we will study. Now first is that nitrogen combines with oxygen to form nitric oxide. Nitrogen combines with oxygen to form nitric oxide. Now this is the principal reaction for the formation of nitric acid, that is Ostwald process. Now second is, that is action as a oxidizing agent. Phosphorus combines with nitric acid to form phosphoric acid, arsenic acid, antimony, and that is antimony oxide, bismuth as bismuth nitrate. And these two products are common. All these elements when combined with nitric acid, the common products are nitrogen dioxide and water. So you can remember phosphorus to phosphoric acid, arsenic to arsenic acid, antimony to antimony oxide, and bismuth to bismuth nitrate. And the common byproduct in all these reactions are nitrogen dioxide and water. Now action of hot concentrated sulfuric acid. Phosphorus combines, this is also again the same, there it was formed nitrogen dioxide and water, here sulfur dioxide and water are the common byproduct. Phosphorus, phosphoric acid, arsenic acid, and this is common, sulfur dioxide and water is common. Antimony sulfate, bismuth sulfate. So they have written in, we have written this as in brackets, means these two products are common in all the four reactions. Next is phosphorus reacts with aqueous alkali solution. Very important reaction, many times it has been asked reaction to complete the following reaction. So phosphorus reacts with sodium hydroxide and water, it forms phosphine and sodium metaphosphite. Now it reacts with metals like magnesium to form nitrites and phosphites. Nitrogen will combine with magnesium, it will form magnesium nitrite. Phosphorus combines with magnesium to form magnesium phosphite. So reaction with metals. Similarly, here we can also take the other metals like, that is, once again, zinc plus antimony, it forms, that is, Zn3Sb. It is called zinc antimonide. Similarly, that is, magnesium reacts with bismuth, it forms, that is, Mg3Bi2. So it is called as magnesium bismuthide. Likewise, so that is, these non-metals combines with metals to form binary compounds. Next, that is, these elements can form hydrides. Now, what are hydrides? Hydrides, when the hydrogen exists with these non-metals in the negative oxidation state, they form hydrides. So the elements nitrogen, phosphorus, arsenic, antimony, bismuth, all of them, they combine with nitrogen. These all combines with hydrogen. So nitrogen will form ammonia. Then phosphorus, phosphine, arsenic, arsine, antimony, bismuthine, antimony, then bismuthine, Bi, this is B capital, BiH3. So these are called hydrides. So just now it is all form hydrides with formula EH3, where E is nitrogen, phosphorus, arsenic, antimony, bismuth, and the oxidation state of these element is -3, and hydrogen again, that is here hydride -1. Now in these hydrides, only nitrogen, that is hydride of nitrogen, can form hydrogen bonding, NH3. NH3, it can form hydrogen bonding, therefore it exists as liquid, because in general ammonia stays in liquid state, but when it forms hydrogen bonding, it exists as a liquid state. Then boiling point of ammonia will be higher than phosphine. Again you will answer due to intermolecular hydrogen bonding. Intermolecular hydrogen. This class in class 11th you have studied, the same answer you will do. Now stability of the hydrides. The stability of the hydrides decreases down the group because of decrease in bond dissociation energy down the group. Because you can see here the size of the elements as we move down the group decreases, and the overlapping between the hydrogen and the metal will go on decreasing. As a result, we can break these bonds very easily. That is why the stability of the hydride decreases down the group. फिर से बता रहे हैं कि नाइट्रोजन से जैसे जैसे हम नीचे जाएंगे इन एलिमेंट्स का साइज बड़ा होता जाएगा. जब एलिमेंट्स का साइज बड़ा होगा तो हाइड्रोजन के साथ जब रिएक्शन करेंगे, कंपाउंड बनाएंगे, तो ओवरलैपिंग उतनी ज़्यादा नहीं हो पाएगी. तो बॉन्ड डिसोसिएशन कम एनर्जी देके ही उसको हम लोग तोड़ सकते हैं. इसलिए ऊपर से नीचे जाते हैं तो इसकी स्टेबिलिटी घटती जाती है. ये पूछा जाता है अरेंज दीज हाइड्राइड्स इन द इंक्रीजिंग और डिक्रीजिंग ऑर्डर ऑफ देयर स्टेबिलिटी. तो सबसे ज़्यादा स्टेबल अमोनिया का होता है और सबसे कम स्टेबल इसका होता है. दूसरा चीज़, सिर्फ अमोनिया ही हाइड्रोजन बॉन्डिंग बना पाता है. रेस्ट ऑफ द एलिमेंट्स डू नॉट फॉर्म हाइड्रोजन बॉन्डिंग. Now comparison of the hydrides, that is basic strength. Now basic strength, as we move down the group the basic strength decreases. Now here the basicity is due to the tendency to donate the lone pair of electron. Now as you move down the group the basic character or the basic strength decreases. The ammonia is the most basic and the bismuthine is the least stable. So as reason is given, as the size of central atom increases electron density decreases. जो आपका suppose this is the element और एलिमेंट के अंदर इस तरह से आपके हाइड्रोजन जुड़े हुए हैं तो इस पे और एक लोन पेयर ऑफ इलेक्ट्रॉन इस पे रहता है. तो ये इलेक्ट्रॉन पेयर जो जितनी आसानी से दे देगा वो उतना ज़्यादा बेसिक है. तो जैसे जैसे ऊपर से नीचे जाते हैं ई का साइज़ बड़ा होता जाता है तो इस पे जो इलेक्ट्रॉन डेंसिटी और ज़्यादा जगह पे रहेगी, इसको और ज़्यादा जगह पे फैलना पड़ेगा, इस वजह से ये दे नहीं पाएगा. सो इसकी जो बेसिक कैरेक्टर ऊपर से नीचे जाएंगे तो घटता जाता है. सेकेंड इज़ थर्मल स्टेबिलिटी ऑफ MH3. तो ये भी अभी जस्ट बताया ये कि स्टेबिलिटी नीचे घट जाती है, तो सेम वही ऑर्डर यहाँ भी होगा कि थर्मल स्टेबिलिटी डिक्रीजेज डाउन द ग्रुप बिकॉज एज द size of the central atom increases the tendency to form stable MH bond decreases. साइज बड़ा होता जाएगा, ओवरलैपिंग कम होती जाएगी तो बॉन्ड डिसोसिएशन एनर्जी कम हो जाएगी, अनस्टेबल बॉन्ड हो जाएगा. थर्ड इज रिड्यूसिंग कैरेक्टर. अब जो जितनी आसानी से H आयन देगा, जितनी आसानी से हाइड्रोजन दे देगा वो उतना ही अच्छा रिड्यूसिंग एजेंट होगा. तभी आपने ऊपर पढ़ा कि ऊपर से नीचे जाते हैं तो थर्मल स्टेबिलिटी घटती जाती है. इसका मतलब बिस्मिथीन जो है सबसे आराम से हाइड्रोजन दे देगा, इसका तो सबसे अच्छा रिड्यूसिंग एजेंट. BiH3 विल बी द बेस्ट रिड्यूसिंग एजेंट. BiH3 जो है इस ग्रुप में बेस्ट रिड्यूसिंग एजेंट होगा. अमोनिया इसमें सबसे कम होगा. तो ये एज द स्टेबिलिटी ऑफ हाइड्राइड डिक्रीजेज द रिड्यूसिंग कैरेक्टर इंक्रीजेज. एंड द लास्ट पॉइंट इज मेल्टिंग पॉइंट एंड बॉइलिंग पॉइंट. melting point and boiling point except in nitrogen it goes on increasing. The melting point increases as we move down the group, but ammonia has the highest melting point and boiling point. Then was this question just now I have told also, due to hydrogen bonding, and you know only 3 atoms in the periodic table can form hydrogen bonding with hydrogen, that is nitrogen, फ्लोरीन एंड ऑक्सीजन. इनके अलावा कोई बनाता ही नहीं है, तो कोई कन्फ्यूजन ही नहीं होनी चाहिए. वाटर, HF, अमोनिया ये हाइड्रोजन बॉन्डिंग बनाते हैं, तो वही उनका हमेशा बॉइलिंग पॉइंट और मेल्टिंग पॉइंट ज़्यादा होगा एज़ कम्पेयर टू द नेक्स्ट एलिमेंट का जो भी कंपाउंड बनेगा उससे हिसाब से. अब हाइड्रोजन बॉन्डिंग नहीं बना पाएगा तो उनके बीच का जो है फोर्स ऑफ अट्रैक्शन उतना ही कमज़ोर रहेगा. तो अमोनिया बनाता है हाइड्रोजन बॉन्डिंग, और फॉस्फीन बनाता है, फॉस्फीन इज ऑल्सो अ गैस, इट फॉर्म्स दैट इज वन डर वाल्स फोर्स ऑफ अट्रैक्शन. तो जैसे जैसे मॉलिक्यूलर साइज बढ़ेगा द वन डर वाल्स फोर्स ऑफ अट्रैक्शन विल गो ऑन डिक्रीजिंग. Now all the elements of the second period, they do not show similar property to the rest of the elements. For example, now nitrogen is the representative element of the 15th group. Now all of them are solids except nitrogen. Nitrogen is gas, rest of them are solid. Nitrogen is diatomic, rest of them are tetraatomic. Nitrogen can form hydrogen bonding, whereas rest of them cannot in hydrides. Nitrogen can form multiple bond, rest of them cannot form multiple bond. That is, nitrogen has triple bond in it. The oxidation state in nitrogen, it ranges from -3 to +5, whereas the rest of the elements have variable oxidation state, but not, the range is not this much. And nitrogen, due to the absence of d orbital, cannot form coordination compound or more than one compound. They will show the oxidation state between, that is, it will show only of 3, that is NCl3 is formed, NCl5 is not formed. Now next is, that is nitrogen. This chapter is slightly boring, but you have to learn it, because now we do not know which kind of paper they will ask. If it is, suppose it is totally objective, then you will find difficulty if you leave anything. So please go through it. Now nitrogen is called dinitrogen because it exists as diatomic molecule. The commercial method of preparation is, number 1, that is fractional distillation of air. When the air is undergoes fractional distillation and liquefaction, liquid nitrogen has boiling point 77.2, so it distills out first, leaving behind liquid oxygen. In the lab, this is the lab method. In the lab, it reacts with, that is ammonium chloride reacts with sodium nitrite. Sodium nitrite, it forms nitrogen, water and sodium chloride. If we want to prepare in ultra pure, then we can prepare it from, that is, this is ultra pure nitrogen from azides, that is NaN3 gives you 2Na plus 3N2. So this is sodium nitrite, gives you sodium plus nitrogen. Then one more is there, that is barium azide. Barium azide, Ba(N3) whole twice, it will give you Ba plus 3N2. So sodium azide as well as barium azide. There is one more method. If you heat ammonium dichromate, NH4 whole twice Cr2O7, this will also give you nitrogen plus water plus Cr2O3. Now this reaction is used to prepare artificial volcano. You can take a volcano like structure in which small aperture, they fill that complete hole with ammonium dichromate and ignite it. So due to the pressure of the nitrogen gas formed in the that hole, the green color Cr2O3 comes out vigorously, gives us the illusion of volcano. Now physical properties of nitrogen. Physical properties of nitrogen. Number 1, it is colorless. Odorless, tasteless, non-toxic, very low solubility in water, low freezing and boiling point, now nitrogen, this is very important question, that is nitrogen is inert at room temperature. Nitrogen is inert at room temperature because of high bond dissociation energy, high bond dissociation energy, N triple bond and now as we move down the group, the reactivity increases with increase in temperature. Now nitrogen can directly combines with the elements to form compounds. You can see here, first, that is nitrogen exists as in two allotropic forms, N14 and N15. Now allotropic I said, it is isotopic form. Now what are isotopes? The elements having same atomic number but different mass number, they are called isotopes. So nitrogen exists in two allotropes, N14 and N15. Combines with metals, or you can say elements also here, because different metals, non-metals both are present. So magnesium combined with nitrogen to form magnesium nitride. Hydrogen combines with nitrogen at a temperature 773 Kelvin, 200 atmosphere, it forms ammonia. Now this process is called Haber's process. This is called Haber's process, and on the basis of the Le-Chatelier principle, these conditions are given. Next is N2 plus O2 gives you nitric oxide. Now calcium carbide, combines with nitrogen to form calcium cyanamide, which is a fertilizer, Baki this all of you know, this is nitric oxide. Now first, that is uses of nitrogen is left, so we will do this two uses of nitrogen. Uses of nitrogen. Number 1, preparation of ammonia, nitric oxide, then calcium cyanamide. Number 2, it is used to provide inert atmosphere. Some of the reaction takes place in the absence of other gases, so to provide inert atmosphere. For example, in iron and steel industry, industries. Next is that liquid nitrogen is used as refrigerant. Liquid nitrogen is used as refrigerants. And to preserve biological specimens. Next, also used in cryosurgery. The next topic is preparation of ammonia. First is, that is lab method. Ammonia is prepared by heating a mixture of calcium hydroxide, this is calcium hydroxide, and ammonium chloride to form calcium chloride, ammonia and water. Now here the ammonia is collected by upward method of upward displacement of water, because it is lighter than air and dried over calcium oxide. Some more methods are there. Now second method is, that is ammonium sulfate plus sodium hydroxide. It gives you, that is ammonia plus sodium sulfate plus water, and the simplest method, that is nitrogen combines with hydrogen to form ammonia. Now, manufacture of ammonia on large scale. So here you can see the diagram. That is manufacture of ammonia on large scale. Here nitrogen gas and hydrogen gas in the ratio of 1:3 is passed through a compressor, because these gases has to be liquefied, so they are passed through compressor. Then the mixture, this nitrogen and hydrogen, then they are passed through a catalytic chamber. Their temperature is low, but it is of 450 to 500 degrees centigrade, and pressure is high, 200 to 900 atmosphere. Catalyst is iron, and promoter is, that is catalytic promoter is molybdenum. Ammonia is formed, but in this chamber the nitrogen and hydrogen, they do not completely combine. Some amount of these gases are left behind, so the nitrogen formed is taken to again condenser, and it is collected in the form of liquid ammonia, and so the unreacted gases, that is N2 and H2, is again sent back to the compressor chamber, and again this process is repeated. So there is a principle, that is Le Chatelier's principle. Sometimes question is asked कि explain on the basis of Le Chatelier's principle what are the conditions required for the preparation of ammonia. Again this is revision only, already you have done. N2 plus 3H2 gives you 2NH3. You do not remember the temperature, no problem, but conditions high low you can write down. Now first is concentration. Increase the concentration. Formation of ammonia. This I am writing for favorable conditions of manufacture of ammonia. So concentration increase the concentration, formation of ammonia will increase. Second is, that is temperature. Now this reaction is exothermic reaction, that is plus Q calories. So in Le Chatelier's principle, always if you increase the temperature, the reaction favors the endothermic process, but this reaction is exothermic process, so low temperature will be required. Low temperature. And third condition is pressure. Now pressure is that if add the number of moles in reactant and product side, and those side will be favored, that side will be favored which has less number of moles. Here it is 1 plus 3, 4, and here it is only 2. So if you increase the pressure, then formation of ammonia will be favored. And last is, that is catalyst. Now catalyst here is iron, and catalytic promoter is MO. Now Haber's process, the same it is, that is how it is prepared. So we will repeat once again. That is manufacture method. So nitrogen combines with hydrogen to form ammonia, temperature 700 degrees centigrade and pressure 200 atmosphere. That is the nowadays this catalyst can also be used, aluminum oxide, ferric oxide, potassium oxide, so to improve the performance. And third, now these are the properties of catalyst, that is the catalyst should be finally divided, तोड़ के उसका सरफेस एरिया बढ़ाया जाता है तो रिएक्शन और तेज़ी से होगी. रिएक्शन रिवर्सिबल होता है, इसलिए जो है पॉसिबल नहीं कि सारे के सारे रिएक्टेंट्स अमोनिया में कन्वर्ट ही हो जाएं, लेकिन कुछ अधिकतर कन्वर्ट हो जाते हैं. और अमोनिया को हमें जो है कन्वर्ट कर मतलब सेपरेट करना है तो हमें ठंडा करना पड़ता है. टू सेपरेट अमोनिया फ्रॉम द मिक्सचर it is cooled, only ammonia liquefies and rest of them do not, and the uncombined nitrogen and oxygen are recycled. Diagram में हमने explain किया, the same thing is written here also. Now ammonia is highly soluble in water, so it gets dissolved in water to form ammonium hydroxide. Now this reaction shows that ammonia is basic in nature. Ammonia is basic in nature. Now, structure of ammonia. Here you can see that nitrogen combines with 3 hydrogen. This bond is towards the observer, this is away from observer, and the bond angle is 107 degree 8 minutes. The structure actually is tetrahedral, sp3 hybridized it is, but it shows not tetrahedral, pyramidal structure. Pyramidal structure. So again one question is asked कि why it has the bond angle 107 degree 8 minutes, because of the repulsion between the lone pair and bond pair. The bond angle changes from 109 degree 28 minutes to 107 degree 8 minutes due to repulsion between lone pair and bond pair of electrons. You can see the structure is trigonal bipyramidal. Trigonal bipyramidal. Now, physical properties of ammonia. Number 1, colorless. Number 2, pungent odor. Freezing point freezing point 198.4 Kelvin, boiling point 239.7 Kelvin. It has high, already we have discussed, high melting and boiling point due to intermolecular hydrogen bonding. Next is chemical properties of ammonia. Ammonia reacts with oxygen to form nitrogen and water. Second is ammonia reacts with oxygen to form nitric oxide and water. Ammonia reduces copper 2 oxides to copper. CO plus NH3 gives you Cu plus H2O plus N2. Thirdly, it is basic in nature. Therefore it combines with the acidic salt to form, combines with acid to form salt, you can say. Third is halogens. Now this combines with, this question, this is very important, many times it has been asked. It combines with chlorine, it forms ammonium chloride and nitrogen. But if ammonia, here ammonia is in less amount and if it is in more amount, नोटिस यहाँ पे हमको क्लोरीन लेना होगा और यहाँ पे क्लोरीन हाई है, एक्सेस है. ये रिएक्शन एक्चुअली आपको पढ़ना है ग्रुप नंबर 17, यहाँ ज़बरदस्ती है. हाँ, सो अमोनिया reacts with excess of chlorine to form NCl3 explosive. NCl3 is explosive. Now ammonia acts as a ligand. Now ligand, this we will discuss. A species which has the tendency to donate a pair of electron is called ligand. So ammonia solution, it combines with copper ion to form, that is tetraamine cuprous ion, and you can write down that is Cu2 plus. In practicals we are doing, it will form Cu NH3 whole 4 2 plus. Similarly, that is when ammonia reacts with silver chloride, it forms, that is Ag NH3 whole twice Cl, that is diamine silver chloride. This is tetraamine copper ion. So when we will do the practicals in group 2 for the analysis of copper, we use ammonium hydroxide. In group 3, aluminum, iron, chromium, again ammonium hydroxide is used. They are precipitated in the form of hydroxides. Now so that is when ammonia dissolves in water, it forms ammonium hydroxide. So due to presence of hydroxyl ion, it is weakly basic in nature, weakly basic. Now when it combines with sodium hypochlorite, it forms hydrazine. It forms hydrazine. Next is, this is the test for ammonium ion. Test for ammonium ion. When we add sodium hydroxide to a salt containing ammonium ion, smell of ammonia gas comes out. Then we add Nessler's reagent. Its formula is K2HgI4. It forms, that is, brown PPT. Brown PPT, and it is called as Millions base. So very important test for ammonium ion, zero group element. Now uses of ammonia. Ammonia is used in the manufacture of fertilizer like ammonium sulfate. It is also used in softening of water, that is removal of hardness of water. It is used in making nitric acid, used in making plastics, used in making many compounds. So in today's video we have studied about the 15th group property, physical and chemical properties of 15th group elements, then properties, preparation properties and uses of ammonia and nitrogen.